Hi guys, this is Calc video 6-7 for Monday, February 13th. There's no homework associated with this video. And here's an example. Let R be the region bounded by the graph of y equals radical x, the line y equals 3, and the y-axis. So first we'll draw that region, then we'll find the area of the region, and then we will set up but not integrate an expression for the volume of the solid formed when r is revolved around the x-axis. So we'll just set up the integral, but we won't actually find a value for it. Okay, so first guys, I would like you to just write something down up here. So a washer is, okay, a washer looks like this. All right, it looks like a disc, but there's an empty space inside of it. Okay, so draw this on your picture. So that's a washer. And a washer has like a small radius for the empty part, and then it has a bigger radius. So the small radius goes from the center to the beginning of the shaded region, and the big radius goes from the center to the end of the shaded region. So the area of this shaded region is pi big R squared minus little r squared. Okay, so we're going to be using that today. Okay, so first let's draw the region. We've got y equals radical x. So that looks like this. All right, so we've got y equals radical x, and then we've got the line y equals 3. Okay, so I'll draw it like this. Okay, y equals 3. So y equals radical x, y equals 3, and the y-axis. Okay, so there's the y-axis. So x equals 0 is the y-axis. So I'm looking for the intersection points of these lines and the y-axis. So there's one, here's another, and then there's a third. So those are the vertices of the region. So here is the region that we're working with. So this is 0, 0. This is, I know that the y coordinate is 3, okay, because that's y equals 3. So I know the y coordinate is 3. So if y is 3, what is x? So if you were to plug 3 in for y right there, you'd have to square both sides to find x. So x would be 9. Okay, and then this is 0, 3. Okay, so first we want to find the area of R. Okay, so for the area, you ask yourself which line test this passes. Does it pass the vertical line test? Yes. Okay, so any vertical line through this region would intersect each graph only once. Okay, so it passes the vertical line test. So we could use the top minus bottom one, where everything's in terms of x. But it also passes the horizontal line test, where each horizontal line through the region intersects each graph only once. So we could use either area formula, top minus bottom, everything in terms of x, or right minus left, everything in terms of y. Y is already solved for, so I'll use the top minus bottom one. So for the area of R, we would do the integral from x equals a to b, top minus bottom dx. Okay, and in this case, this would be x equals, the smallest x for the region is 0, the highest x for the region is 9, and then I need top minus bottom. Okay, so it's helpful if you just like draw a little vertical line, top minus bottom, top minus bottom. So the top function is 3, the bottom function is radical x. So 3 minus radical x would go inside. And I think I already found this with a calculator. No, it looks like I did the fundamental theorem when I was doing my notes, but I'll just use a calculator, guys, to speed things up. So if you needed to plug that in your calculator, you would actually get 9. Okay, a very nice area. Okay, Now for 2, so this was number 1. Now for number 2, it wants us to set up but do not integrate an expression for the volume of the solid formed when R is revolved around the x-axis. So we're revolving around the x-axis. Oopsie. We're revolving around the x-axis. So I made a big one of this. Okay, so here's this thing. All right, this represents that region, and I'm revolving around the blue stick, which in this case represents the x-axis. So when you do this, guys, all right, actually, let me say this. Okay, now pretend, let me just go about my business like I think this is one from, like the ones we've been practicing before. Okay, so I do revolves around, and then I say cross section, and then area. So it revolves around the x-axis. Okay, so everything will be in terms of x. Now for the cross section, when you're figuring out the cross section, you go to the axis you're revolving around. So I'm revolving around this axis. I go close to the region. Guys, notice the region is not right up against what we're revolving around. There's some space there. So I just go kind of like under the region, and I put a dot, and that is the center of my cross section. And then I draw a line all the way to the end of the region. So that would be my radius. But guys, notice there's this empty space here. Okay, if you look at the radius of my cross section, there's some empty space that it falls on. So the reason, or because of this, so let me show you what the solid thing would look like. Okay, so here's this, and I'm revolving around the x-axis. So as this region sweeps through the air, you know, it picks up all this volume, and it makes this solid shape. But there will be empty space in the middle. So it's kind of like, think of it as a bowl. So it's not a solid, it's like when you do a cross section, you're going to have some empty space in the middle. Okay, so just like, so visualize that. All right, so actually, we're going to have 2 radii. We're going to have this inner radius, okay, from the center of your cross section to the beginning of, to where the region begins. That's going to be this like little, that'll be little r, that'll be the inner radius. So that's the empty space. And then from the center of your cross section to the end of the region, that's going to be like this. That's going to be the big radius. Okay, so when you revolve the empty space, okay, so revolving the empty space, you'd get like this circle right there. And then if you revolve, you know, the rest of the region, it would go like this. Okay, so this is where like the shaded region, when the shaded area sweeps through the space, it would become this. But then you'd have this empty space inside. So you actually have a washer as the cross section. Okay, so the cross section, it's going to be like this. So there's the center of it, and then there's the big radius, and then I'll have like the little radius there. I feel like I'm being very inarticulate. Okay, so there's the center, little radius, big radius. All right, and then I'll complete the rest of it. So that'll be the little circle inside. There's the big circle. Okay, so instead of being a disc, the cross section is what's called a washer. So I need to find the big radius and the little radius. So the big radius is the whole length of this here, okay, from the center to where the region ends. So it's a vertical length, so I'll do top minus bottom, 3 minus 0. So the big radius is 3. Oops. The little radius is just this like empty space right here. So it's vertical again, so top minus bottom, top minus bottom. So radical x minus 0, radical x minus 0. So little r is radical x minus 0, so just radical x. And then for the area, this is a washer. So the area is pi, big R squared minus little r squared. So it is pi, big R squared is 9, minus little r squared is just x. Okay, so that's the area of this cross section right here. And then to find the volume, we would just add up, so everything's in terms of x, so x from 0 to 9, and then we would just add up an infinite number of these areas, so pi 9 minus x, and we can stop there. Okay, it said set up but do not integrate. Okay, so right there. Okay guys, so basically you'll know that your cross section is a disc if you've got like, if between the center of the cross section and the region there is a gap. Okay, so we're gonna do another one. Okay, so this one here, the region R is bounded by the curve y equals the natural log of x and the lines y equals 0 and x equals e to the third. Find the volume of the solid generated by revolving R around the y-axis. I'll go a little bit faster this time. I forgot there was a second example, so I was taking my time before. Okay, so here's this. Okay, so y equals natural log of x. That looks like that. Okay. E to the x equals e to the third. Okay, so this is y equals natural log of x. X equals e to the third. That's going to be a vertical line. X equals e to the third. And y equals 0. Okay, so right there. So let me find my region first by getting the vertices of it. So I'm looking for the intersection points of these three things. All right, so here's the region. This is e to the third, comma 0. This is 1, 0. And then this up here is e to the third, comma, to get the y coordinate, guys, you could just plug into there. Natural log of e to the third is 3. Okay, so there's those. Now we're revolving around the y-axis. Okay, so revolving around the y-axis, we're revolving around here. I'm going to use my chart in a moment, but first let me get thinking about my cross section. So I'm going to move along my axis of rotation until I get close to my region. So see how the region now is immediately to the right. So that's going to be the center of rotation. To here, that'll be little r, and then all the way to the end will be big R. Okay, so little r, big R. Okay, so I know that this is going to be a washer because there is some empty space between my center of rotation and the region, and where the region begins. There's some empty space. Okay, so when I revolve this part, I'll get this empty part, and when I revolve the rest of it, okay, so you'll get that washer. Okay, so let me do my chart. So revolves around cross-section and area. So it's revolving around the y-axis. So we actually want everything in terms of y. So as soon as I realize this, I've got to solve for x. Okay, so I go up here. So y equals natural log of x, or you do that, you know, roll it up thing that some of you say, which is great. So I go x equals e to the y. If that's not clear to you what I just said, then just remember when you're converting, so log base a of x equals y. If you want to convert to exponential notation, that would be a to the y equals x. And natural log is log base e. Okay, so I just really just converted from logarithmic notation to exponential notation, and I had x solved for. Okay, so now for my cross section. Okay, so it's going to be, so there's the center of it. Little r, big R. There's the inner circle, outer circle. Okay, so I need big R. So since this is a horizontal length, I have to do right minus left. Okay, so for big R, right minus left, right minus left. So this is e to the third minus 0. So e to the third minus 0 is capital R, so just e to the third. And now lowercase r, right minus left, so e to the y minus 0, e to the y minus 0. Okay, so e to the y for little r. So now our area is going to be pi, and then I need big R squared minus little r squared. So big R squared is going to be e to the third squared, so e to the sixth, and then little r squared is e to the y squared, so e to the 2y. So that's the area. And now I just have to get the volume. Okay, the lowest y value is 0. The highest y value is 3 dy. And then what goes in here is the areas. So pi e to the sixth minus e to the 2y. And I already plugged this in my calculator. I got 3,170.093. So that would be the volume. Okay, guys, have a great day. See you soon.